Hey, welcome to this third video of Electromagnetic Engineering and Radiating System, Lecture 3. In previous videos, we studied basic terminologies such as scalars and vectors, and then we discussed about the vector algebra in that dot product and cross product. Right, so in this particular segment of video, we will see what is del operator, how it operates on a scalar and vector quantities, and then we will study coordinate systems. Right, so let's begin with the del operator. So basically del operator is a differentiation function which is defined as del is equal to dou by dou x a bar x plus dou by dou y a bar y plus dou by dou z a bar z. Right, now this operator, basically this itself is a vector quantity because it involves all the direction components. Now when it operates on a scalar, it can operate on scalar as well as on vector quantity. So when it operates on a scalar quantity, it is termed as a gradient, and when it operates on a vector quantity, it operates in two ways basically. It operates on a vector quantity in a dot product, and it operates on a vector quantity with a cross product. So we will talk on that later on. Before that, let us understand the gradient. As I said, when del operator operates on a scalar quantity, it is called as a gradient. So let us assume a scalar quantity V. So gradient of V is equal to, that is what grad V is equal to del V, right? So when we multiply this, del V is equal to dou by dou x a bar x plus dou by dou y a bar y plus dou by dou z a bar z multiplied by V is equal to dou v by dou x a bar x plus dou v by dou y a bar y plus dou v by dou z a bar z. So this is the result of gradient, and it result in a vector quantity. You can observe a bar x, a bar y and a bar z unit vectors are included in this equation. That means it's a vector quantity. So gradient results in vector. Next is a divergence. So when I say del operates on a vector quantity with a dot product, we will call it as a divergence. So let us assume one of the vector a bar is equal to ax a bar x plus ay a bar y plus az a bar z. So let us take a divergence of it. So that del dot a bar is equal to div, that is divergence dot a bar is equal to dou by dou x a bar x plus dou by dou y a bar y plus dou by dou z a bar z dot the vector a bar, that is ax a bar x plus ay a bar y plus az a bar z. So if you go through the definition of dot product, I think we have discussed one of the definition for dot product between a bar and v bar, a bar and b bar. So if you are having two vectors a bar and b bar, we do the dot product between them, such as a bar dot b bar as ax bx plus ay by plus az bz. So similarly, we take the x component, y component and z component, multiplication between them, and finally we add those terms. So finally we get divergence of A is equal to dou ax by dou x plus dou ay by dou y plus dou az by dou z. So this is the result of divergence, and this results in a scalar quantity. As you can see, there are no unit vectors or direction components are involved in this equation. So this is a scalar quantity. So divergence results in scalar. Next is a curl. So when del operates on a vector quantity with a cross product, we call it as a curl. So let us once again take a vector a bar is equal to ax a bar x plus ay a bar y plus az a bar z. So curl of that vector is equal to del cross a bar is equal to, in determinant, all the unit vectors are arranged in first row a bar x, a bar y, a bar z. In the second row, x y z component of first vector, that is dou by dou x, dou by dou y, dou by dou z, and x y z component of